Assalamu alaikum. Hi, how are you? Grade 12. Today, inshallah, we starting together with kinematics. This is the second chapter. The first chapter is vectors cancelled. Today, inshallah, we're going to start together in first chapter. The chapter's name is kinematics. Okay, let's go for the notes. This is the notation mechanics or kinematics. First, this is the syllabus contains. Then, together, we need to define what is the mechanics. What is mechanics? The study of physics begins with the mechanics. Mechanics is the branch of physics that focuses on the motions of objects and the forces that causes the motions to change. There are two parts to mechanics, kinematics and dynamics. Kinematics deals with the concepts that are needed to describe motion without any reference to forces. Dynamics deals with the effects that forces have on motion. Okay, we need now to compare between kinematics and dynamics because it's included from one branch, it's mechanics. Let's go for this video to see what is the difference between mechanics and dynamics. Yes, now this is the difference between kinematics and dynamics. First, what's kinematics? We know that before. Kinematics is the branch of mechanics connected with the motion of object without reference to the forces with the causes the motions. For example, let us consider a particle that began accelerated along straight line with a constant acceleration. Okay, constant acceleration. The constant acceleration, what is the symbol for acceleration? Let's go for A. The symbol A, the particle has an initial velocity of u. Initial velocity of u. Initial velocity of u. Yes, initial velocity of u. Yes, the particles has the initial velocity of u. U is initial velocity, and after a time t, the velocity of particle is v. Using equation of motion for a particle with the constant acceleration, we can calculate it. We can calculate the final velocity to be v final. It's equal u is initial and a is acceleration, t is time. Now, like this object's movement from position A and this position B, yes, we call this the initial and this is final, okay, with time t. This is the symbol use of kinematics. We have not detailed with this causes of motions. We have simply made a calculation with regards to what kinematic quantities. Okay. Okay, this is the definition for kinematics. This is the definition for kinematics. Okay. Okay, this is the symbol of use kinematics. We have not detail with the causes of the motions. We have only simply made a calculation with regard to kinematics quantities. Okay, again, dynamics, what is this before is kinematics. Now dynamics is the branch of mechanics to study the motion, to study motions along with the factor that causes motions calculation in dynamics, therefore involves mass and forces. For instance, if the particle had a mass m, then according to the Newton's second law, we study later, inshallah. Resultant force is equal F is equal ma. Okay, and again, the difference between kinematics and dynamics, between the definitions, kinematics is the study of motions of particles and bodies without taking into account the factors that causes motions. Kinematics takes into account quantities such as what? Displacement, velocity, and acceleration. But what is the dynamics? Dynamics is the study of motions along with the factors that causes motions. Calculation in dynamics therefore involves masses and forces. Consequently, study of quantities such as a moment can be described as a part of dynamics. The area of study used in applied mathematics, robotics, mechanical engineering, machine, biomechanics, and astrophysics. Applied mathematics, applied mathematics, mechanical engineering. What is the properties? Considers with the properties of motions only, such as velocity, displacement, and acceleration. What is the dynamics? The properties of dynamic considers with the analysis of the forces operating upon any moving body, torque, moments of inertia, and angular momentum can be also classified as dynamics. Okay. Then this is the difference between kinematics and dynamics. Okay. So we're going for first in the kinematics, then we're going for dynamics. Finally, can be memorized then main difference between kinematics and dynamics. Kinematics, study of motions, not considering causes of motions. But dynamics, study of motion with the considering causes of motions. This is the main difference. Okay. Then we return back. The introductions. Kinematics is the science of, we know that before, kinematics is the science of describing the motion of objects using words, diagrams, graphs, and equations. The goal of kinematics is to develop mental models to describe the motions of real-world objects. We will learn to describe motions using words, diagrams, graphs, and equations. Words, explanations of words, diagrams, shape, draw the diagrams, and graph with x-axis and y-axis, and then we'll go in for equations. Describing motions with the words. The motions of the object can be described by words. Even a person without a background in physics has a collecting of words which can be used to describing moving object. For example, like what? Describing words like what? Going faster, stopped, slowing down, speeding up, and turning, provided a sufficient vocabulary for describing the motion of objects. This is the what means by describes by words. In physics, we use these words as the language of kinematics, distance and displacement, speed and velocity, and then acceleration. Okay, these words, which are used to describe the motions of the object, can be divided into two categories. The quantities is either vectors or scalars. Scalars are the quantities which are describing by magnitude only. Vectors are the quantities which are describing by both magnitude and directions. First, now starting again with distance and displacement. Distance and displacement. What is distance? Distance refers to the total length of travel irrespective of the directions of the motions. And what is the displacement? Displacement refers to the distance moved in a particular direction. It is the object overall change in the positions. What about distance? Distance, again, it's the scalar quantities. And the unit, what is the general units? The general unit is meter. Other common units, we know that's kilometer, centimeters, and millimeter, and so on. What is the displacement? Displacement refers to the distance moved in the particular directions. It is the object's overall change in the position. It is a vector quantities, SI unit is meter, other common units, kilometers, centimeter, and so on. Okay, distance and displacement. You drive the path, and your meters goes up. Your distance. Your displacement is the shorter directed distance from start to stop. اللي هي green arrows. See, like this graph between start A and B, start and end point. So the green line, we call this displacement. And what about the red one? Again, start from the same point, start point, and ending to the same point, but take long distance. This we call distance, and this we call displacement. Distance, any displacement equal distance, but not displacement equal distance. This is the point. Okay, example, a student walks 4 meters east, 2 meters south, 4 meters west, and finally 2 meters north. Let's go for to calculate. Either we know 2, 4, and 2. Yes. So we going. Yes. This is example 1. Yeah. This is the example 1. Example 1. Take shape. Shape is rectangle. Rectangle. Shape. Rectangle. Shape. So we need, this is how much? Color. Yes. This is 2 meter. This is 4 meter. And again, this is 2 meter. And this is what we call, this is again 4 meter. If a 2 meter up or north, yes, this is west, and this is south, and this is what? To the east. Okay. So how to calculate? What you should be to calculate it? Number 1, we need to calculate first the distance. What is distance? Distance is the full. Distance is the full. Yes. Distance is equal total. A total between 2, 4, and 2 and 4. This is the total. If it's equal 4, starting from this point, if right, this is point A, then point B, and point C, and point D. So we can write what? 4 plus 2 plus 4 again, and finally 2. How much totally? Totally how much? 4 plus 2, 6. 6 plus 4, 10. 10 plus 2 is 12. 12 what? 12 meters. 12 what? 12 meters. Okay, then what is the displacement? Displacement, how to calculate the displacement? Displacement, how to calculate the displacement? Displacement now, it's depend on the directions. Okay, displacement, what is the direction now? When I'm looking for x-axis, we know it's x-axis, this is x positive, and this is x negative, this is y positive, and this is what? Y negative. So we calculate the distance now. How to calculate the distance? To the north, okay, it's 2 positive plus 4, okay, again positive plus, then again down, to right minus 2 between brackets, yes, minus 2, okay, because opposite to the من A من D to A, it's opposite to B to C, plus minus what? Minus 4. So how to calculate it now? Now the total displacement equal what? Equal 0 meter. There is no change. 0 meter. Why? Because each direction cancel each other. Mean A to B cancel, mean C to D, and mean D to A cancel, mean B to C, because opposite to each other. Then what is the conclusion? The conclusion for any closed shape, the total displacement equals 0. What is the distance? But the distance calculated all. Calculate all. Okay. Next. Return back. Since the total distance is 12 meters, during the course of the motion, the total length of travel is 12 meters. Okay, what is the total displacement? 0. Why 0? Because when he is finished walking, there is no change in the positions. The 4 meter east is cancelled by the 4 meter west, and the 2 meter south is cancelled by the 2 meter north. Okay, now next, what is the speed and what is the velocity? Yes, the speed and velocity. Speed is the rate of the change of the distance, scalar quantity. What is the velocity? Velocity is the distance traveled in the specific directions. It's also defined as the rate of the change of the displacement. See, velocity is the distance traveled in the specific direction. Specific direction, exactly. But we need directions. Okay, so we call what is the velocity? It's vector quantity for this reason. Or we can define as the rate of the change of the displacement. We can write here in the speed is the distance divided by time. What is the velocity? Velocity is what? Velocity is the displacement divided by time. This is scalar quantity and this is the vector quantities. What is the speed? Speed is the distance traveled or time taken, while velocity here is what? Change in the displacement over time taken. When evaluating the velocity of an object, one must keep track of what? For directions. If the direction of the velocity vectors is the same as the direction which an object is moving. It would not matter whether the object is speeding up or slowing down. Okay, for example, if an object is moving rightwards, then it is the velocity is described as began rightwards. We know that Boeing 747 moving towards the west with the speed of 260 meters per second had a velocity of 260 meters per second west. Note that the speed has no direction. Speed has no direction. It is what? Scalar. And the velocity at any instant is simply the speed with what? Speed with directions. Speed with direction. See this? See this? Yeah. This like simulation for what? For the object. We can see here velocity or acceleration. First, we're going for show one. We're going for velocity first. The velocity is going with green arrows. Okay, we're going for this slide. Now the velocity. Now the acceleration is 0, but the velocity we can increasing velocity. There are down. There is a linear acceleration or linear acceleration 1, linear acceleration 2, and this simple harmonic and this circular. And this is stop. See, this is stop here. Circular. Circular is mean movement in circular path, and the other thing is what? It's like simple harmonic. Simple harmonic right and left. Right and left. But we're going for first to the linear acceleration. See now? We're going to how much the acceleration? Acceleration is very slow now, and the velocity. See the velocity increase and decrease. Yes, this is the velocity scale. We can changing the velocity scale. This 8x or 10x. But what about acceleration? Acceleration is 2x. Okay, we can increase the acceleration now. We can increase the acceleration now. But You can the scale, you can see the change between the first motions and the second motions. We can see the first motion and the second motions. Okay, this is the example about the motions. See the difference between kind of motions. This linear, simple harmonic, or circular. Okay, let's go for another stimulation. This another stimulation is given by positions. This is the positions, velocity, and acceleration. We cancel now. Acceleration, we're going between positions and velocity. Now this object, it's man, it's movement right or left. We can add in here any numbers, for example, 5, and then velocity. Velocity, see, in number 5, in 5 meters. Now velocity, it's, for example, 3, and then play, see, it's, yeah, this is stopped again. Okay, we can repeat it, and again, we can see here what happened. Yeah, there is increasing in position, changing in position, and velocity it's constant, and then sudden stopped. Why sudden stop? Because stopped with the end of the path. Okay, again, we can repeat it again. We can see here what happened. See the change between position and velocity. It's increasing, and this is constant one to constant velocity. Okay, we reset all. Okay, again, we can write minus 10, and the velocity increasing to 10, and see what happened. See the directions now. The red arrows means there is velocity, and the blue one means positions. See, now play. Yes, see, this is the motions. We can see there's a direction again, play. See, it's increasing from -5, -10, -5, 0, 5, and 10. And the velocity is constant. See, there is no change in velocity, so let's go what straight line. Why suddenly stopped? Because stopped by the wall. Okay, but directly proportional for positions and constant for velocity. This example about positions and position and velocity. Okay, we return back for the notes again. Okay, instantaneous speed and average speed. Instantaneous speed and average speed. What is the difference? As an object moves, it often undergoes changes in speed. But the speed at any instant is known as the instantaneous speed, from the value of the speed meter, exactly at specific speed. But the average speed of the entire journey can be calculated. How to calculate the average speed? For example, the total distance traveled over the total time taken. Total distance traveled over the total time taken. Yes. Again, the average speed of entry journey can be calculated. The average speed of entry journey can be calculated by this formula, the total distance traveled over the total time taken. Okay, and this is the definition of the speed. The speed at any instance is known as the instantaneous speed. Instantaneous speed. Okay, speed and velocity. What is the difference between speed and velocity? An object is moving in a circular at constant speed of 10 meters per second, or 10 meters second minus 1. We say that it has a constant speed, but its velocity is not what constant. Why? See the directions. This is the directions of motion because the directions of the object keeps what? Changing, keeps changing. So why the object moving in circle or constant speed? Okay. Thank you. We complete inshallah in next lesson.